Hello everybody. So today we're going to talk about CQRS and Event Sourcing. What CQRS stands for is Command and Query Responsibility Segregation. Basically what it means is using different model to update information and read information. So let's talk about the traditional way. So in traditional way we have this magic box and we use same model reading and writing data. And also we might use a CRUD data store to at least get some mental model. For a small application which works okay, but when application gets more bigger and sophisticated, things get more complicated and complex. Now these are the problems of traditional way. One is data contention. What data contention means is when multiple processes competing for access to data block at the same time. And the second one is negative effect on performance. It could happen maybe because of data contention. Also, another thing to consider, in an application, you don't need same performance for reading and writing data. Sometimes you need very high performance reading operation. Sometimes you need very high performance writing operation. And another problem we have is mismatch between the read and write representation. When you are using application and you're using same model, you end up having same data schema. And the thing is, your application may be used by different client, maybe a customer, maybe a salesperson, and they need different type of data. So client has to conform to the data. And there is also the atomic operation for logical unit. Since you are doing all the things one model, making an atomic operation, you may have to block other process. So let's talk about CQRS a bit. This is a diagram of bare mean version of CQRS model. We have a client here on the top. Ideally, you'll have many clients, and this is the command model and this is the query model. So when a client wants to persist some data, it would make command. In the command model, it would persist the data to database. So we have a separate path for writing data, and for query model, we could use a different DB which would be in sync with this database, and the client would query the query model or read model to read data. And another thing here is how do you handle external stuff like email payments integration in this model. So for this, we have this process manager in the middle. Now this model still have some problem. One of the problem is syncing is painful, and in here data representation is still same for writing and reading, and how we're gonna invoke process manager efficiently. So to fix the problem of data representation, we could actually have different models based on the different needs of different clients, and each of the model will have its own way of saving data, or even every model can have their own database. So one of the way this will be populated is we could publish the event from the database to this model and aggregate the model based on the event. For example, let's say we're going to develop an online car reservation system, and maybe a sales team of the company want to know total number of car reserved to the system so far, and also total request of the car reservation per month. So the customer would send a command to reserve car along the car information, and command model would validate and will save the information to database, and then somehow we'll send the event to this model, and in the model we can aggregate the result based on that. And yeah, we can also send all the events to process manager so that process manager can actually process this. For example, like sending email or maybe integrate some payment information. Now in here, we can see here, this database does not have to save any fancy updated result. The query model and process manager, they can build their own state from the events. So you can actually just save the event in the database. So let's switch it with a simple event store here. Now the idea is to save all the events in this event store. So from command model, we can save the event. The nice thing about this approach here is if some service in query model or process model get crashed during any time, we can just replay all the event messages from the event store for the model, and you'll get same data again. If you need to change any schema in the read model, we can just change the schema and replay the messages again, which in the traditional approach not always possible. You might lose some data forever. Now we are storing all the event in the store, and this is actually event sourcing. In event sourcing, there are some rules, and events are immutable and can be stored using an append-only operation. And also events in event store are never deleted. There's one thing I was skipping before is how you do an atomic operation in command model. Like for example, when a customer wants to reserve a car, we don't want to lock other operation like reserving a different car by other client. We can have a content system for each logical unit in the command model, and this content system is called aggregate in CQRS model. Here is a bigger diagram with some example aggregate. And in this case, we can think each car has a separate logical unit, and we can pass the command to aggregate of the correspondent car, and it would create event and store it. And as in for aggregate, it could be any logical unit. It could be aggregate for user, customer, or car. Aggregate could have its own state, which it would use to create event based on command. One tips, using actor model would make your life easy to aggregate. So before I end this, here are the summary. In CQRS, writing is done. In command model, reading is done in query model. And process manager is used for processing external operation. And in event sourcing, we only append events in event store. We never delete any data. So that's all. Thank you everyone.